Hello friends, welcome back to my channel Chemistry with DB. So in this video I am going to explain the electrophilic addition reactions of alkenes, the basic concepts. So first of all, let's see uh, what is that C double bond C is made up from. So you know that one of these bonds is a sigma bond, right, which are all single bonds or sigma bonds, and the other one is a pi bond. Now this pi bond is formed through the sideways overlap of two p orbitals which are dumbbell shaped. So as a result of this gives rise to an electron cloud above and below the plane, right? So this is the electron cloud, and because this is rich in electrons, so therefore this attracts electrophiles. Here I have given you the notes for this one, that the pi bond is weaker than the sigma bond because the shared pair is at a slight distance from the nuclei of the two carbon atoms. So this is why it requires less energy to be overcome. Now the electron rich cloud, which is above and below the plane of the molecule, that attracts electrophiles, and because only one product forms, so this is why it's called an electrophilic addition reaction. Now there can be two types of reactions of electrophilic addition. One with the polar molecules. So polar molecules wherein there is a difference in electronegativity between the atoms involved. For example, H and Cl, chlorine is more electronegative than hydrogen. So this is why chlorine becomes a delta negative and hydrogen is delta positive. And so on and so forth. In case of HBr, oxygen here in water is more electronegative, so oxygen is delta negative, and in HCN, carbon in the nitrile group is the delta negative group. Now all of these delta positive hydrogens are delta positive, so therefore these readily act as an electrophile. However, when we look at a non-polar molecule, for example reaction with Cl2 or Br2 or H2, so in this case there is no difference in electronegativity between the atoms involved. So therefore in the first step what happens is that when this, for example, the Cl molecule approaches this electron cloud here, above and below the double bond, then in that case the electron repulsion, this causes the electrons to move away from this chlorine atom. As a result of this becomes slightly electron deficient, or we can say delta positive, and this chlorine towards which the electrons have gone, this becomes delta negative. Now this delta positive, this one acts as an electrophile, and similarly the electrophiles are generated in case of all other non-polar molecules because of the electron-electron repulsion from the double bond. Now let's look into any kind of a general electrophilic addition reaction. So let's say, for example, what happens when ethene molecule, here is the electron cloud, this reacts with, let's say for example, HCl. Now difference in electronegativity. So chlorine is delta negative, hydrogen is delta positive. So this electrophile is attracted to the electron cloud, double bond breaks, and this hydrogen, which is the electrophile, this joins one of the carbon atoms. Now the other carbon atom is electron deficient, so this becomes a carbocation. Another thing that happens is that the HCl bond breaks by heterolytic fission. Heterolytic fission in which the bond breaks and chlorine takes both the electrons. As a result of this, chlorine becomes a chloride ion. Now this is a chloride ion, is negatively charged, and this is a carbocation which is positively charged. So therefore they are both attracted to each other, electrostatic attraction, and as a result of this you get hydrogen here and the chlorine. or you have got the chloroethane from ethene. So this is how any general reaction mechanism of an electrophilic addition takes place. Now these are the notes which I have given here, so you can read these. Now coming to the conclusion, we can look at the reaction of, let's say for example, ethene with, let's say, HCl. So HCl is a polar molecule. So what happens is one of the carbon gets the hydrogen and the other one gets the chlorine. Reaction with HCN, one carbon gets the H and the other one gets the CN. When the reaction with Cl2, then in that case you get a dichloroethane. When it's a hydrogenation reaction with hydrogen, that takes place in the presence of a nickel catalyst, so you get a ethane. When the reaction is with steam, this is also known as a hydration reaction, because ethane is water molecule is being added to the ethene across the double bond. So then you get a ethanol, which is a alcohol. Reaction with bromine is used to test for the unsaturation or test for a double bond. So what happens in this case is you get a dibromoethane, and the color, which was orange, it becomes colorless. So this is how I have summarized here all of the reactions, electrophilic addition reactions of alkenes. If you want further explanation of how electrophilic addition reactions take place in case of asymmetric alkenes, which involves usage of the Markownikoff's rule and the nature of the carbocations, then in that case please watch my next video, which is the electrophilic addition part 2, and I'll give you the link in the description box here. So thanks for watching, and I look forward to see you on my next video. Bye. Take care.